Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I will continue from the last class. Last class I was discussing question, answer and its explanation based on heat of reaction, or you can tell enthalpies of reactions. Actually I am discussing multiple choice questions based on chemical thermodynamics. Now I will continue. Question I am reading. When 1 mole of H2O2 is decomposed by platinum black, the heat evolved is 96.6 kilojoule. The heat of formation of 1 mole of H2O2 is first option 96.6 kilojoule, second 193.2 kilojoule, third 386.4 kilojoule, fourth 48.3 kilojoule. Again I am repeating the question. When 1 mole of peroxide is decomposed by platinum black, the heat evolved is 96.6 kilojoule. The heat of formation of 1 mole of H2O2 is first option 96.6 kilojoule, second 193.2 kilojoule, third 386.4 kilojoule, fourth 48.3 kilojoule. Just this question will take hardly 15 seconds maximum. Just to think. After that I will tell answer and its explanation. Its correct answer is 96.6 kilojoule. So in question it is given when 1 mole of H2O2 hydrogen peroxide is decomposed by platinum black, the heat evolved is 96.6 kilojoule. The heat of formation of 1 mole of H2O2 is, then its correct answer is 96.6 kilojoule. Same what is given in question, same value. Second value is 193.2, third one is 386.4, fourth one is 48.3 kilojoule. But first one is correct, 96.6 kilojoule. How? Now I am telling you. H2O2, when it will decompose, it will give H2 plus O2. And delta H value is given minus 96.6 kilojoule. Then reverse of this, what will be? This is the decomposition. H2O2 has decomposed and given H2 plus O2, and delta H value is minus 96.6 kilojoule according to the question. But reverse is the formation. Reverse of this is formation, means H2 plus O2, that will give peroxide, then delta H sign will change, means minus will become plus. Hence correct answer is plus 96.6 kilojoule. Hence option A is correct, 96.6 kilojoule. So this question is good. Here delta H value is not given, heat evolved is given. Then heat evolved means heat evolved means delta H is minus 96.6. That is for decomposition. And reverse of this is the formation from H2 and O2. Heat of formation of H2O2 from H2 plus O2. Then its value will be same value but positive sign. Hence correct option is 96.6 kilojoule. Next question. The heats of combustion of hydrogen, carbon monoxide and methane are minus 285, minus 284 and minus 890 kilojoule per mole. The calorific value is maximum for first option H2, second option CO means carbon monoxide, third option CH4 means methane, and last option cannot be predicted as information is incomplete. Fourth option is cannot be predicted as information is incomplete. Again I am reading the question. The heats of combustion of hydrogen, carbon monoxide and methane are minus 285, minus 284 and minus 890 kilojoule per mole respectively. The calorific value is maximum for first option H2, second option CO, third option CH4, fourth option cannot be predicted as information is incomplete. Just to think, this question also you can solve it within 15 seconds. Just to think. Its correct answer is H2, means calorific value is maximum for H2, hydrogen gas. How? Then now I am telling you. See here that calorific value is the heat of combustion per gram. This you remember. Calorific value is the heat of combustion per gram. Then calorific value of H2, that is equal to minus 285 divided by 2, because H2 means 2 gram. H2 means 2 gram. Correct? Then for 2 gram value is minus 285. Then for 1 gram how much? Minus 285 divided by 2. And for carbon monoxide, it will be, again you can say, carbon monoxide means 12 plus 16, 28 gram. Then for 28 gram, its value is, given value is minus 284. Then for 1 gram, minus 284 divided by 28. Then it will be very less. And for methane, now it is given minus 890. Then here CH4, methane means how many gram? Molecular mass. Then 12 plus 4, 16. Then minus 890 divided by 16. This value is also less. Only in the case of hydrogen, it is maximum. Minus 285 by 2 for hydrogen. For carbon monoxide, minus 284 by 28, it is very less. And for methane, minus 890 divided by 16. If you will compare, then you will find for hydrogen, means for 1 gram, hydrogen has maximum value. Hence correct answer is a hydrogen gas, H2. Next question I am reading. For which one of the following elements the standard enthalpy is not 0? For which one of the following elements the standard enthalpy is not 0? First option is carbon, means diamond. Second option is graphite, that is also carbon but graphite. Third option is liquid mercury. Fourth option, rhombic sulfur. Again I am repeating the question. For which one of the following elements the standard enthalpy is not 0? First option, diamond. Second option, graphite. Third option, liquid mercury. Fourth option, rhombic sulfur. Just to think, this you can answer within 5 seconds. I have discussed this type of question. Okay. Now you just to think. After that I will give answer and explanation. Its correct answer is diamond. Okay, diamond has you can say 1.86 kilojoule, its value, not 0, but graphite is 0. Okay, and other liquid mercury also 0, rhombic sulfur also 0. Only diamond is not 0. Its value is 1.86 kilojoule per mole. Hence this correct answer is diamond. Okay, and heat of formation, standard heat of formation for diamond is not 0, that you remember. Next question I am reading. If the heat of solution for 1 mole of KCl in 20 moles of water and 200 moles of water are plus 3.80 kilocalorie and plus 4.40 kilocalorie respectively, then the heat of dilution is. Again I am repeating the question. If the heat of solution for 1 mole of KCl in 20 moles of water and 200 moles of water are plus 3.80 kilocalorie and plus 4.80 kilocalorie respectively, then the heat of dilution is. First option, plus 8.20. Second option, minus 8.2 kilocalorie. Third option, plus 0.60 kilocalorie. And fourth option, minus 0.60 kilocalorie. Just you think. Again option I am telling you. First option, plus 8.20 kilocalorie. Second option, minus 8.2 kilocalorie. Third option, 0.60 kilocalorie. Fourth option, minus 0.60 kilocalorie. Okay, just you think. After that I will give answer and explanation. It's actually can answer it within 10 seconds, maximum 10 seconds. Just to think. Its correct answer is plus 0.60 kilocalorie. See, 1 mole is dissolved. When 1 mole is dissolved in 20 ml water, then that time heat of dilution is given plus 3.80. And when it is dissolved in 200 moles of water, KCl is 1 mole. KCl is 1 mole when it is dissolved in 20 ml water. Then heat of dilution is plus 3.80, and when it is dissolved, 1 mole of KCl is dissolved in 200 moles of water, then its value is plus 4.40 kilocalorie. Then you have to tell heat of dilution. Then heat of dilution is just a difference of these two, means 4.40 minus 3.80 means plus 0.60 kilocalorie. That is the difference, 3.80. Correct? Then from 4.40, this you deduct this value. Then difference will come 0.60 kilocalorie. Option C is correct. Actually, heat of dilution is the heat change. Heat change when a solution containing 1 mole of the solute is diluted from one concentration to another. Then just you have to make a change. Then option C is correct, 0.60 kilocalorie. Now, next question. 1 mole of H2SO4 is mixed with 2 moles of NOH. The heat evolved will be, first option 57.3 kilojoule, second 2 into 57.3 kilojoule, third option 57.3 divided by 2 kilojoule, fourth option cannot be predicted. Again, I am telling you, I am reading the question. Second time, 1 mole of H2SO4 is mixed with 2 moles of NOH. 1 mole of H2SO4 is mixed with 2 moles of NOH. The heat evolved will be, first option 57.3 kilojoule, second option 2 into 57.3 kilojoule, third option 57.3 divided by 2 kilojoule, fourth option cannot be predicted. Just you think this you can answer maximum by 30 seconds. Okay, less than that. You think it is full based on concept. Its correct answer is 2 into 57.3 kilojoule. 2 into 57.3 kilojoule. Okay, why? Now if you read the question, then it will be clear. 1 mole of H2SO4, 1 mole of H2SO4, 2 H is there, H2SO4 is mixed with 2 moles of NOH, means 2 OH is there. Correct? Then here 1 mole of H2SO4 is equivalent to 2 gram equivalent of H2SO4. 1 mole of H2SO4 means you can say 2 gram equivalent of H2SO4. Hence for 1 gram equivalent value is 57.3. Then for 2 gram equivalent, what will be the value? Just you multiply by 2 into 57.3. Correct? Because it is this 2 is reacting with 2 mole of NOH. Correct? Hence value will be double. Next question. The heat of combustion of solid benzoic acid at constant volume is minus 321.30 kilojoule at 27 degrees centigrade. The heat of combustion at constant pressure is, first option minus 321.30 minus 300 R, second minus 321.30 plus 300 R, third option minus 321.30 minus 150 R, Fourth option, minus 321.30 plus 900 R. Again, I am repeating the question. Listen carefully. The heat of combustion of solid benzoic acid at constant volume is minus 321.80 kilojoule at 27 degree centigrade. The heat of combustion at constant pressure is, first option, minus 321.30 minus 300 R. Second, minus 321.30 plus 300 R. Third option, minus 321.30 minus 150 R. Fourth option, minus 321.30 plus 900 R. Just you think. Actually, this also will take hardly 30 seconds. Just to think. It is based on concept and formula. If you are remembering the formula, quickly you can solve it. Because at constant value, heat of combustion at constant value is given. You have to calculate at constant pressure. Heat of combustion at constant pressure. Just you think. After that I will tell answer and explanation. See, its a correct answer is a third option, minus 321.30 minus 150 R. How? Now we have to think. See, benzoic acid is C6H5COOH. It is a solid. When it will react completely, for combustion it should react completely. Then in balanced equation it will come 7.5 O2. Means 15 divided by 2 O2. Benzoic acid plus 7.5 O2 means oxygen gas. It will give 7 CO2 plus 3 H2O. Correct? Benzoic acid solid when it will react by 15 by 2 O2 means 7.5. It will give 7 CO2 plus 3 H2O liquid. Then what is the change in a number of moles? Then product side, how many moles are there? Product side, how many moles are there? NP minus NR. NP means a number of moles of product and NR number of moles of reactant in gaseous state. Then you can see that it forms 7 CO2, 7 mole of CO2 plus 3 H2O liquid. The liquid you have to not calculate. You should remember that only for gaseous molecules only you have to compare in reactant side and product side. Only molecules in gaseous state, not the solid, not the liquid. Benzoic acid you have to not consider because it is solid. Only 15 by O2 that you can consider because it is gaseous. And product side 7 CO2 is there. 7 CO2 plus 3 H2O, that is a liquid. Then liquid moles you have to not consider. Product side and reactant side, benzoic acid you have to not consider. Then product side 7 CO2 means 7 moles minus 15 by 2 O2 means 7.5. You have to consider. Then you will get minus 0.5. Minus 0.5, that is the difference, delta N. Delta N is equal to minus 0.5. Then now formula is there. You are knowing QP is equal to QV plus delta N RT. QP means product pressure at constant pressure Q. Correct? That is the combustion this thing value at a constant pressure. QP is equal to QV means at constant volume plus delta N RT. Then QV value is given in the question minus 321.30 plus now delta N you have calculated minus 0.5 RT. Then T you have to add 273. This 273. This delta N value I have written, and this R and T. Then here delta N is equal to what? Delta N is equal to minus 0.5. Correct? Then in formula you put all the things. The minus 321.30 plus in bracket you write minus 0.5 divided by 273 plus 27 degree. Okay, you add, is a given 27 degrees centigrade, it will come 300 T 300 R you can write, 300 R value don't write, not given, write only R. Then minus 0.5 means half you can write, then 300 divided by 2, 300 minus 300 divided by 2 means 150 R. Hence you will get value minus 321.30 minus 150 R. Correct? Hence correct answer is third option, minus 321.30 minus 150 R. Why it become minus? Because difference is minus 0.5 means minus half. Then 273 plus 27. Temperature is given 27 degree. Add it. It become 300. Then 300 divided by 2, 150. And R is there. You write R only. And so you will get minus 321.30 minus 150 R. Hence correct option is C. Next question. The heat, actually this question is very, very important. This question can be asked in exam, competitive examination, this type of question. Okay, in both, in engineering and in medical, both can be asked. Next question. The heat of formation of H2O liquid is minus 68.0 kilocalorie. The heat of formation of H2O gas is likely to be, first option, minus 68.0 kilocalorie. Second, minus 69.4 kilocalorie. Third, 80.0 kilocalorie. Fourth, minus 58.3 kilocalorie. Again I am repeating the question. The heat of formation of H2O liquid is minus 68.0 kilocalorie. Then heat of formation means gaseous state, in gaseous state is likely to be, first option, minus 68.0 kilocalorie. Second, minus 69.4 kilocalorie. Third, 80.0 kilocalorie. Fourth, 58.3 kilocalorie. Just to think, this answer, this question also you can solve it within 30 seconds. Just to think. After that I will tell answer and explanation. Now I am telling the answer. Its correct answer is 58.3 kilocalorie minus 58.3 kilocalorie. Option D. How? Now I am telling you question again. I am reading then you can understand. The heat of formation of H2O liquid is minus 68.0 kilocalorie. The heat of formation of H2O gas, a gaseous state, is likely to be. Option is given for option minus 68.0 kilocalorie. Second option minus 69.4 kilocalorie. Third 80.0 kilocalorie. Fourth is minus 58.3 kilocalorie. Then its correct answer is minus 58.3 kilocalorie. Option D. Option D. How? Now I am telling you. In H2O is liquid. From the liquid, now you are converting it in gaseous state. H2O gas, from liquid to gas. Correct? Then in that situation, heat is absorbed because it is liquid. And now liquid you are converting to gas. Then you have to supply heat. Only then liquid will convert to gas or vapor. Then here some heat will be absorbed. Correct? Heat is absorbed. Hence delta HF, standard delta H value for H2O gas will be less than delta H, standard delta HF value of H2O liquid. Correct? Because here heat is absorbed, then it will evolve less. Because some heat is absorbed. Hence you will not get full like minus 68.0. You will get less. Then it will be minus 58.3. Exactly I am not telling, but it will be certainly less. Then in given option, all three are more. In minus it is more. Only D is less than minus 68.0. Now fourth is minus 58.3. Means it will release less energy. Less heat it will release. Hence correct option is D. Now next question. Heat of formation delta means delta H, standard delta HF of an explosive compound like NCl3 is first option positive, second option negative, third option 0, fourth option positive or negative. Again I am repeating the question. Heat of formation, that is a standard delta HF of an explosive compound like NCl3 is first option positive, second option negative, third option 0, fourth option positive or negative. Just to think, this also by seeing you can tell the answer. 5 seconds is sufficient. It is just based on concept. Just to think. After that I will tell answer and explanation. Its correct answer is positive. Heat of formation, that is just delta H value will be positive. Okay. Why it is positive? Just here remember delta H of this is the explosive compound. Example is given like NCl3. Then here this NCl3 is going to be explode. Then what will be heat of formation? Positive, negative, 0, something will be there. Then its correct answer is positive. Why it is positive? Then now just you think change in change in a number of moles in gaseous state. Delta N will be Np minus Nr. Np minus Nr. Then here product that is a NCl3, when it will explode, it will break. Then it will break. Then here product will be, the product will get, total number of product will be 4. Number of moles of product side, it will be 4 in gaseous state, and reactant will be 2 moles only, and 4 minus 2, that is the 2, and so delta H is equal to delta E plus delta N RT. Then here delta H value will be more than delta E, because delta N is 2 in positive value is there, 4 minus 2. Then that's just like a 2NS3 when it breaks, that is a dissociation of ammonia, NS3, 2NS3, how much it will give product? H2 plus 3H2, total 4. Like that way NCl3 is there. Same way it will give 4 product. 2 in the place of 2NS3, you write 2NS3, NCl3. You will get 4 product, same way. Then 4 minus 2, delta N is a plus 2. Hence in formula delta H is equal to delta E plus delta N RT. Then obviously delta H value is greater than delta E. Then answer will be positive only. Hence correct answer is option A, positive. Now next question I am discussing. The heats of neutralization of 4 acids A, B, C and D when neutralized against a common base are 13.7, 9.4, 11.2 and 12.4 kilocalorie respectively. The biggest among these acids is first option A, second option B, third option C, fourth option D. Again I am repeating, this very good question. The heats of neutralization of 4 acids A, B, C, D when neutralized against a common base. Base is common, means A, B, C, D all will react with the same base. Value is given. For the A, its value is 13.7. For B, 9.4. For C, 11.2. For D, it is a 12.4 kilocalorie respectively. The biggest among these acids is, which one is weak, that you tell. First option A, second option B, third option C, fourth option D. You can answer hardly less than 10 seconds. Just to think, and after that I will tell answer and explanation. Now its correct answer is B. Option B also and B, because by seeing the value you can understand which one is weakest. See, when both are strong, then value will be maximum. Delta H will be negative, value will be maximum. Correct? Then here this 4 value is given, 13.7. First, that is for a strongest you can tell. A strong acid, a strong base. Second is 9.4. Third is 11.2. Fourth is 12.4. Then whose value is less than 9.4 among 4? It means that will be weakest among these acid. That's why it is releasing least value 9.4, and option B is correct. Here variation of heat of reaction, these things I am talking about these things, heat of neutralization. Then here less the heat of neutralization, weakest is the acid, and so the correct answer is B, 9.4. B option is correct. B means the second acid, 9.4. That is the weakest. Now next question. For the reaction 2NH3, it decomposes and it gives N2 plus 3H2. Both are gas. Ammonia is also gas. 2NH3 gas decomposes and gives N2 plus 3H2 gas. Correct? Then which of the statement is correct? First, delta H is equal to delta H is equal to delta E. Second, delta H is greater than equal to delta E. Fourth option, delta H is greater than delta E. Fourth option, delta H is equal to 0. Again I am telling you, for the reaction 2NH3 gas, it is giving N2 gas plus 3H2 gas. Now we have to tell which of the following statement is correct. Delta H is equal to delta E, and second, delta H is greater than delta E. Third option, delta H is greater than delta E. Actually second option was delta H is greater than equal to delta E. Third option, delta H is greater than delta E. Fourth option, delta H is equal to 0. This also quickly we can answer, full of concept. Within 10 seconds you can answer by seeing the question. If you are knowing the concept, already I have discussed. Just to think. After that I will tell answer and explanation. Its correct answer is delta H is greater than delta E. Delta H is greater than delta E. Why? Now you can understand that you just to count the number of moles of reactant and product. Then product side N2 plus 3H2 means total 4. 1 N2, 3H2, total 4. Product side only 2, all are in gaseous state. 4 minus 2, that is the 2, means delta N value is plus 2. Then now you put in the formula, delta H is equal to delta E plus delta NG delta N RT in gaseous state. Then you will find delta H is greater than delta E, because you are putting 2 in the place of delta, and obviously it will be greater than delta E, and so delta E plus 2 into RT, so obviously it will be more, and so delta H is greater than delta E. Now next question I am telling you. The equation giving variation of heat of a reaction with temperature is known as: first, Kirchhoff's equation; second, want of isotherm; third, want of isochore; fourth, Hess law. Again I am repeating. The equation giving variation of heat of a reaction with temperature is known as: first option, Kirchhoff's equation; second, want of isotherm; third, want of isochore; fourth, Hess law. This also you can answer quickly if you are remembering this equation, okay, this law, just to think. Again I am telling, first option is, question is the equation giving variation of heat of a reaction with temperature is known as Kirchhoff's equation. Second, want of isotherm. Third, want of isochore. Fourth, Hess law. Just to think. After that I will tell the answer and explanation. Its a correct answer is Kirchhoff's equation. Kirchhoff's equation means option A. Just to remember the, I can say, statement. What is that? Variation of heat of reaction with temperature is given by Kirchhoff's equation. Correct? This is the statement. Kirchhoff equation. Variation of heat of reaction with temperature is given by Kirchhoff's equation. Okay. Now next question I am telling you. The heat of combustion of a reaction does not depend on, first option, physical state of the substance. Second, temperature at which combustion carried out. Third, amount of oxygen present. Fourth, whether the combustion is carried out in an open vessel or a closed vessel. Again I am repeating the question. The heat of combustion of a reaction does not depend on, first, physical state of the substance. Second, temperature at which combustion is carried out. Third, amount of oxygen present. Fourth, whether the combustion is carried out in an open vessel or a closed vessel. Just to think, this also you can answer very quickly, less than 10 seconds. Just to think. After that I will tell answer and explanation. Its correct answer is amount of oxygen present. In combustion reaction, oxygen is the main things. Oxygen is required for complete combustion. Hence, it depends on amount of oxygen present. Okay, this remember. Heat of combustion does not actually I told you. Question is the heat of combustion. The heat of combustion of a reaction does not depend on. First option was physical state of the substance. Second, temperature at which combustion is carried out. Correct? Third was amount of oxygen present. Fourth, whether the combustion is carried out in an open vessel or a closed vessel. Its correct answer is amount of oxygen present. Here you should understand, heat of combustion of a reaction does not depend on. Then here for combustion always excess amount is present. Actually it depends upon physical state. Correct? It depends upon physical state of the substance. It depends upon temperature at which combustion is carried out, and this also depends upon whether combustion is carried out in an open vessel or closed vessel. In all 3 points it depends. But amount of oxygen, actually oxygen is must, that is correct. But in combustion, always oxygen will be excess. Always oxygen will be excess. This is very good question. It is not asking only presence of oxygen, but in combustion reaction, if combustion reaction is there, then excess oxygen will be there. You are talking about excess oxygen. Then heat of combustion does not depend upon the amount of oxygen present, which is always in excess. Correct? Always a reaction will take place in presence of excess oxygen. One more question I want to discuss. The enthalpy of formation of ammonia is minus 46.0 kilojoule per mole. The enthalpy change for the reaction 2NH3 gas, it is giving 2N2 plus 3, this is wrong, question is written wrong, N2 plus 3H2. In question they have written 2N2, I have to correct it. Okay, 2NH3, it will give N2 plus 3H2. This reaction is given. Then now you have to tell, question is the enthalpy of formation of ammonia. The enthalpy of formation of ammonia is minus 46.0 kilojoule per mole. This is the enthalpy of formation of ammonia, and reaction is given 2NH3, it is giving N2 plus 3H2 gas. Then value is given, first option 46 kilojoule per mole, second 92.0 kilojoule per mole, third minus 23.0 kilojoule per mole, fourth minus 92.0 kilojoule per mole. Again I am repeating the question. The enthalpy of formation of ammonia is minus 46.0 kilojoule per mole. The enthalpy change, you have to calculate enthalpy change. The enthalpy change for the reaction 2NH3, it is giving N2 plus 3H2 gas, is first option 46 kilojoule per mole, second 92.0 kilojoule per mole, third minus 23 kilojoule per mole, fourth minus 92.0 kilojoule per mole. This is a good question and it will take around 30 seconds just to think. After that I will tell correct answer and explanation. Its correct answer is 92.0 kilojoule per mole. 92.0 kilojoule per mole. Second option is correct. Then now how that I am telling you, listen carefully. See, N2 plus, for 1 mole actually you have to calculate. Then N2 plus Cy2H2, that will be give 1 mole. For actually what is given, that is for 2 mole. 2NH3 is giving N2 plus 3H2. Then for 1 mole you have to calculate change of enthalpy, that is calculated per mole. Then here 2NH3 is giving N2 plus 3H2. This you keep in mind. Then for 1 mole, for the formation of 1 mole NH3, it requires N2 plus 3Y2H2. Correct? Then its value actually is, it will be minus 46.0 kilojoule. Then for 2N2, what will be 2N2 plus 3H2? It is giving 2NH3. Correct? Here you have to consider, according to the question, 2N2 plus 3H2. It will give 2NH3. And but for 1 mole, it is 46 minus 46 kilojoule. That is for 1 mole. You know, for this delta H, for that delta H, 1 mole is required. Formation of 1 mole NH3 from the N2 and H2. Then for balanced equation, N2, 1 mole N2 and 1.5 H2. That will give 1 NH3. And delta H will be minus 46 kilojoule. But in the given equation, all are 2 moles. It is given 2N2 plus 3H2. It will give 2NH3. 2NH3. Correct? Then for this, what will be the value? Well, value will be double. 2 minus 46.0 means minus 92.0 kilojoule. Correct? Again, you try to understand that for the 2NH3, for the given question, it is a 2NH3 formation. 2NH3 after decomposition is giving 2N2 plus 2N2 it will not give, because only N2 will give. Question is, I will correct, it is not balanced. Okay. Then 2 for the 2NH3, you will get after decomposition N2 plus 3H2. Then reverse it. Then that is for N2 plus 3H2. That gives 2NH3. For 2 mole you have to calculate. Then obviously whatever for 1 mole value is minus 46. Then for 2 mole it will be double. Very simple way. And correct answer will be 92.0 kilojoule. Okay, that heat will be evolved. Today I am stopping only here. Here it will be not minus, it will be plus, because you have reversed the reaction. You have reversed the reaction. Okay, minus 46 was there. Now it is coming 42, because question is asking the enthalpy change of the reaction. Enthalpy change of the reaction it is asking, and in the question it is giving enthalpy of formation. Enthalpy of formation value is minus 46 kilojoule per mole. And you have to calculate enthalpy change of the reaction. Now 2NH3, it is giving N2 plus 3H2. Correct? There it was formation. NH3 was forming. Now given question is, from NH3 you are getting N2 plus 3H2, and sign will be opposite. Correct? Then it will be plus value 92.0. And today I am stopping only here. Next class again I will continue. Thank you.